Section 5.3 is easy. I just wrote 12 problems. Each of the problems is essentially the same problem. Each of the problem gives me a bit of information that it wants me to satisfy. Specifically, each problem wants me to create a function that has a lead coefficient of 1, which means a 1 in front of the term with the highest exponent, that satisfies conditions. Here, the condition in problem 2 is degree 2, which means I'm creating a function that has highest exponent of 2. That's what degree 2 means. And zeros, x equal to positive 4i and x equal to negative 4i. A 0 is a value for x that you can plug into the original function and get 0. Super easy to create that. I'm going to take the zeros that are given, turn them into factors, just like we did in the last section where I got numbers that had y coordinates of zeros from my graphing table, and I turned those numbers into factors for factoring purposes. This is just like that. The numbers that I got from the quadratic, from my graph, I turned into factors in the last section. I'm going to do that again. The polynomial, or the function that I'm going to need, is going to be found by multiplying x minus 4i times x plus 4i. I'm just going to FOIL these out and combine like terms. My firsts are x times x. My outers are x times 4i. My inners are minus 4i times x. And my lasts are minus 4i times positive 4i. The function that's going to have a highest exponent of 2 and zeros of 4i and negative 4i is going to be found when I simplify this. My x times x is x squared. My x times 4i, I'm going to write as positive 4xi. My negative 4i times x, I'm going to write as negative 4xi. I guess I probably could have wrote ix. It doesn't matter. It almost looks strange having the I where I have it, but it doesn't matter. My lasts are minus 4 times minus 4, which is minus 16, and I times I, which is I squared. Regardless of how I decided to write the inners and outers, they're going to cancel, so they're really irrelevant. And the polynomial that I'm going to get is f of x is x squared minus 16i squared. And of course, I squared is equal to negative 1. So this polynomial is f of x minus f of x equals x squared minus a negative 16, because the 16 times negative 1 is a negative 16. My answer to number 12, number 2, is going to be f of x equals x squared plus 16. I can tell if my answer is right if positive and negative 4i are both zeros. So if I wanted to check, it should happen that when I change the x to positive 4i, or if I change the x to negative 4i, it has to happen that I get 0. If I put 4i in for the x and simplify and I don't get 0, then I've made a mistake. I can check this on my calculator if I put it in the right mode. If I turn my calculator on, hit the mode button, go and make sure my calculator is in A plus BI mode, which is a mode that will handle i's. So mode, and my calculator is by default, I leave it in A plus BI mode. So both my calculators are in A plus BI mode. So I'm going to just do this checking, CF parentheses 4, and then I have to remember where the I is. The I is on the decimal, and it's written in blue. So I hit the second key in decimal, parentheses squared, and then plus 16. So this is what I get when I change the x to 4i. And my answer, this is a 0, only if when I hit enter, it comes back with a 0. If I don't get 0 when I hit enter, then I haven't created a proper function, because 4i needs to be a 0 of my function, which means if I change the x to 4i and evaluate it, I should get 0, which I do. On my other calculator, if I do negative on the bottom row of the calculator, 4 second and decimal for I squared plus 16 gives me 0 just fine. So I've created the function that I needed to just fine. Gets a little harder, and the order that I do my multiplication in is going to be a big deal here. So in problem 4, I'm trying to create a polynomial with degree 3. So my answer is going to have an x cubed as the first term. The instructions say create a function with this degree with lead coefficient of 1. So my first term needs to be 1x cubed. And my zeros are x equal to negative 5, x equals to positive 3i, and x equal to negative 3i. I'm going to turn my zeros into factors. The x equal to negative 5 will turn into the factor of x plus 5. The x equal to positive 3i turns into the factor of x minus 3i. And the x equals negative 3i, if I add 3i to both sides, turns into the factor positive x plus 3i. The function I need is the product of these three. Super convenient if you decide. The best idea in doing this is to do the multiplication in an order that makes your work easiest. That's to do the I bits first. Now I'm going to start and do this multiplication, do my firsts, outers, inners, and lasts. And this multiplication gives me x squared plus 3xi minus 3xi plus 9i squared, actually minus 9i squared. And so that first parentheses, I can simplify it by my foiling. The 3xi's cancel when I foil those first two factorings, and I'm left with x squared minus 9i squared times x plus 5. The minus 9i squared is really minus 9 times minus 1 because I squared is equal to minus 1. So I can rewrite the first parentheses as x squared plus 9. And I'll just FOIL again and get my polynomial. I'll multiply x squared times x and get x cubed. I'll multiply x squared times 5 and get 5x squared. I'll multiply 9 times x and get 9x. I'll multiply 9 times 5 and get positive 45. I claim that this is the answer. Let me check to make sure that 3i is a 0. So I'm just going to check one of these. I'm going to plug in x equal to 3i. Checking is not required, but I can. I think I can. I don't think my calculator is going to blow up on me. Sometimes my calculator doesn't do well with i's, but I think it can handle this. My answer is only right if when I plug this in, I get a 0. So let me hope that I didn't do something that stretches my calculator's ability. So 3i cubed plus 5 times 3i squared plus 9 times 3i plus 45. And I get 0 just fine. I could check the other ones exactly the same way. I don't have to check, but I can check every single, to make sure that this answer is right. You can take each one of these individual zeros, plug it in for x, and each one of them should come out to be a 0. I should do number 5 with you because this is where it has the trick. So I'm going to do 5 as opposed to 7. And there's a theorem that comes about with zeros that have i's, and it's called the complex conjugate root theorem. Basically says that if a polynomial has a plus bi as a root, then a minus bi as a root. What this means that if 5 plus 6i was a 0, then 5 minus 6i would also have to be a 0. Similarly, if a polynomial has positive negative 9i as a 0, positive 9i would be also a 0. So it turns out that you can't just have a positive solution when you have an I as a 0. If you're told that a positive value with an I or a positive imaginary number is a 0, that also means its negative is also. They always come in pairs. Imaginary roots or imaginary zeros always come in pairs. There's always a positive with a negative. And so this problem 5, although it didn't say that negative 3i was a 0, it is, using that complex conjugate theorem. So my zeros for this are x equal to positive 2, x equal to positive 3i, and x equal to negative 3i. The x equal to positive 2 would give a factor of x minus 2. The x equal to positive 3i gives a factor of x minus 3i, and the x equal to negative 3i gives a factor of x plus 3i. To create my function, I'm going to multiply these three factors, doing the i's first. To do the i's, I could be lazy and not do all 4 parts of the foiling because I know the outers and inners are going to cancel, but I'll pretend that I didn't know that. For my foiling, I do x times x, which equals x squared, x times 3i, which is positive 3xi, minus 3 to I times x, which is minus 3xi, and then minus 3i times positive 3i, that's minus 9i squared. That's going to give me an x squared. Outers and inners will cancel. And for the last, it's minus 9i squared. The I squared is equal to negative 1, so that's minus 9 times minus 1, which is positive 9. That's doing the first multiplication. Now I'll finish up and multiply by the x minus 2. I'm going to go x times x squared times x, and get x cubed. Do x squared times minus 2 and get minus 2x squared. 9 times x and get positive 9x. 9 times minus 2 and get minus 18. I claim that this function, f of x equals x cubed minus 2x squared plus 9x minus 18, is the function that will have the 3 desired zeros. Seven and 8, I want a degree 4 function. So when I go to write my answer, the first term has to be x to the 4th, and then I could have several terms after it. But the instructions tell me I want a 4th degree term here, and the seed instructions say I want a 1 in front of the square term, or in this case the 4th power term, 1 in front of the leading coefficient. And in this problem, I have to use that complex root theorem that says if x equal to positive 3i is a 0, then so is negative 3i. If x equals positive 4i is a 0, so is negative 3i. So my 4 zeros are x equal to 3i, x equal to minus 3i, x equal to 4i, and x equal to minus 4i, which means my factors are going to be x minus 3i from the x equal 3i, x plus 3i from the x equal negative 3i, x minus 4i from the x equal to 4i, and x plus 4i from the x equal to negative 4i. If you multiply this out cleverly, you can get the work done a lot nicer. I'm going to multiply those first and get those down to a single parentheses. These second, get those 2 parentheses simplified to a single parentheses, and then have 2 parentheses that I can multiply together. So this first multiplication, I'm going to do first x times x and get an x squared. Outers, x times 3i and get a positive 3xi. Inners, minus 3i times x, get a minus 3xi. Lasts, minus 3i times 3i and get a negative 9i squared. And the 3xi's are going to cancel. And I'm going to get an x squared plus 9, because this minus 9i squared is minus 9 times minus 1, which is positive 9. The next pair of multiplying I'll do, is I'll do firsts of x times x, which are x squared. Outers are x times 4i, which is plus 4xi. Inners, minus 4i times x is minus 4xi. Lasts, minus 4i times positive 4i is minus 16i squared. The 4xi's cancel. I'm left with x squared, and it's going to wind up being plus 16, because at the very end here you have minus 16 times I squared, which is minus 16 times minus 1, which is a positive 16. Now I'm just going to FOIL this out. And this might be too much for my calculator to check. I'm afraid to try plugging the numbers in. My cheap calculator that I might use in another class can't do I to the 4th. But anyways, let's FOIL this. Firsts are x squared times x squared, which is x to the 4th. Outers are x squared times 16, which is plus 16x squared. Inners are 9 times x squared, which is plus 9x squared. Lasts are 9 times 16, which is, I believe, plus 144. Ooh, is that right? I think it's right. So I'd say the answer to this is f of x equals x to the 4th plus 25x squared plus 144, which means I should be able to take 4i, 3i, negative 3i, or negative 4i and plug it into the function and get 0. I'm going to do this off screen. If my calculator works, then I'll show it on screen. I'm just not sure what my calculator does with I to the 4th. It might be just, like I said, it might be too much for my calculator. If it works, I'll show you that it works. If not, I don't want to teach you how to check by hand for this one problem. Yes, it blew my calculator. My calculator couldn't handle this. Let me make sure I don't have a mistake. X squared plus 9, check. X squared plus 16, check. Let me make sure 9 times 16 is 144. Yeah. This is a correct answer, best I can tell. I don't see any mistakes. I tried to do this off screen on my old calculator. I'll try to check it off screen on my new calculator. I just don't think it's going to check on my calculator, and I don't want to check this by hand because it's just not that important to do the checking here. That worked on this one. So on this calculator, maybe I entered it wrong on my last calculator. To check, I should be able to take any of the 4 zeros, 4i, negative 4i, positive 3i, or negative 3i, plug them in. Instead of x to the 4th, put your 0 to the 4th. And then instead of plus 25x squared, put your 0 in there, plus 144. It's only right if when you hit equals, you get 0 for all 4 of them, not just for one of them. 9 and 10, I'm going to exploit my calculator. Well, maybe I won't. I could exploit my calculator. I don't think I have to. So multiplying is going to be a little bit harder. On number 10, it says it wants degree 2, so it's going to lead off with an x squared term. And it says one of the zeros is 4i. The other one has to be minus 4 minus I. So my zeros are x equal to 4 plus I and x equal to 4 minus I. For the 4 plus I, I'm going to minus 4 and minus I from both sides and get x minus 4 minus I is one of my factors. And for the other one, I'm going to minus 4 and plus I from both sides and get x minus 4 plus I is my other factor. So the polynomial that I need to create is going to be x minus 4 minus I times x minus 4 plus I. 9 multiplications to do. First, 3 multiplications. Take the x in the first parentheses, multiply it by the x in the second parentheses, the x in the first parentheses times the negative 4 in the second parentheses, the x in the first parentheses times the I in the second parentheses. My first multiplication gives me x squared minus 4x plus xi. Second 3 multiplications, take the negative 4 in the first parentheses multiply it by each of the three terms in the second parentheses. Multiply minus 4 times x, minus 4 times minus 4, and minus 4 times I. So the second set of multiplication gives me minus 4x plus 16 minus 4i. Notice instead of writing it horizontally, I'm starting to write it vertically, lining like terms up under each other. That's to make the simplifying easier. Last three multiplications, I take the negative I in the left parentheses. I multiply negative I times x, negative I times negative 4, and negative I times positive I. The negative I times x I write as negative xi, lining it up in a good place. The negative I times negative 4 is positive 4i, putting it in a good linear place. And the negative I times I is negative I squared. So in terms of a function, I see x squared minus 4x and minus 4x that's right, is minus 8x. These cancel, those cancel. I have plus 16, and this minus I squared is really minus a negative 1 because I squared is equal to a negative 1. And so that's going to give me 16 plus 1. I claim that the answer is x squared minus 8x plus 17, which means if I did the quadratic formula, my answer should be 4 plus I and 4 minus I. I wrote a program for the quadratic formula in this calculator. I'm just going to use it and see if it works for i's. So my a is 1, b is negative. Well, this is not necessary. Let me just check this for you. I don't need to run this program. Let me just check this. How would I check this? I want to see if I plug in 4 plus I for x or 4 minus I for x, I should get 0. I'm just going to check this to make sure my answer is right by going parentheses 4 plus second decimal for I squared minus 8 times parentheses 4 plus second decimal for I plus 17. My answer is only right if I get a 0 and I hit equals, which I do. I could do the same with the minus I, just enter the problem and change the plus sign to a minus. And it gives me the same 0. So one more to do. Exactly the same problem, well, with different numbers. So let's do 11 together. So for 11, wants me to have a degree 2, which means my leading term is going to be an x squared. Tells me that 5 minus I is a 0, so I know that 5 plus I is also a 0. So my zeros are x equals 5 minus I and x equals 5 plus I. One of my factors is going to be x minus 5 minus I. The other factor, actually it should be plus I here, because I should have plussed. The other factor is going to be x minus 5 minus I. So I'm going to multiply together x minus 5 plus I times x minus 5 minus I, doing my 9 multiplications. First, x times x, x squared. Second, x times minus 5, minus 5x. Third, x times minus I, minus xi. Fourth, minus 5 times x, minus 5x. Minus 5 times minus 5, plus 25. Minus 5 times minus I, minus 5i. So that's 6 of 9. Seventh, I times x, that's plus xi. I times minus 5, that is, there's a sign error here. this might, oh, I'm going to come back and fix this mistake in a second. When I do I times minus 5, I get minus 5i, and then I times minus I is minus I squared. This green multiplication that I did minus 5 times minus I. I should have gotten positive 5i here, because a negative times a negative should have been a positive. I kind of knew that my i's needed to start canceling out, and because I didn't, I figured I made a mistake. I'm going to bring down the x squared. The double negative 5x's combine to be negative 10x. The xi's cancel, the 5i's cancel, and I'm left with plus 25 minus I squared. The minus I squared is really minus a negative 1, and a minus a negative 1 is the same as a plus 1. So my answer for number 11 is going to be f of x equals x squared minus 10x plus 26. Not going to check that on screen just because it's going to take time, and that's not really necessary. Yeah, it works just fine. All right, so that's everything for the section. Section 5.4 is a long, probably 3-part section. It's not particularly hard. There's a chunk of theory that we need to get down, but none of it's that hard. And then 5.5 is real short again, and then we end the chapter.